today we can actually continue with your second lecture on vectors 1. Okay, so a few things you must so-called activate from the secondary school will be the properties of certain geometrical shapes. You learn this in your secondary 2 geometry. Okay, what are the properties of a parallelogram? What are the properties of a square? What are the properties of a rectangle? Can you still remember? What makes a shape a parallelogram? Okay, if you cannot actually remember, I listed out the 4 so-called conditions, A, B, C, D, that makes a shape a parallelogram. So, yeah, let's look at the items bit by bit. If I tell you, let's look at A. AB, vector AB is equals to vector DC. What does 2 equal vector tell you? Can you recall? Vector equals to vector. That's actually implying 2 items. Can you remember what things? That means, if I tell you just AB vector is equals to DC vector, it will mean that vector AB is parallel to vector DC. Agree? To tell you the first thing. What else will they tell you? Number 2, what else will they tell you? The length is also the same, right? The length of AB is also the same as the length of DC. So, if I want to prove that ABCD is a parallelogram, this one, enough already. A is enough. One condition is enough to conclude that ABCD is a parallelogram. If you don't want, you can use B. I prove vector AD is equals to vector BC. Also can. But if you don't want to use equal, you choose to use parallel. Can I say AB parallel to DC alone and then I can conclude that they are parallel? This is a parallelogram? Cannot. Okay? If you just want to use a condition on parallel, you need double condition. AB parallel to DC, AB parallel to DC. AB, DC, AB, DC. Yeah. Okay? So you need double condition. So the choice is yours. What actually comes to your brain during the exam, activate and use it accordingly. And can you please asterisk D? Because this thing is usually the one that students always forget. Sometimes things like this get asked during the exam. The diagonals bisect each other. This is another feature of your parallelogram that's often omitted by students. Okay, but if I ask you to prove there's a parallelogram, my suggestion is just use A or B straight away. Don't use all the other things. Okay, so that's a parallelogram. Rhombus? Wait, that's you now. Is a rhombus a parallelogram? Is a parallelogram a rhombus? Okay, so very good. So parallelogram is not a rhombus. So what it means, rhombus have additional properties that parallelogram don't have, right? Okay, so that's how you remember. And then similarly, square have additional properties that parallelogram don't have. Okay? So what is the additional property that a rhombus have? The 4 sides must be equal in length, right? So you must tell me 2 things now. AB vector is equals to DC vector, and at the same time, AB vector is equals to AD, length. Okay? So telling me that they are parallel, not enough. You must also tell me that they are equal in length. Wait, where is it? Okay, so you must tell me this one. And can take note now. AB equals to AB vector equals to DC vector, and then I say the length of AB and AD. We're talking about different stuff. Okay, so you use any of these items, you will be able to prove that it is a rhombus. So what is the extra feature? Even the diagonals. This one, please take note. The diagonals of your we call that rhombus bisect each other at right angle. Oi, what happened to my notes? Gone. what has happened before in the A levels is that they have tested things like this. Parallelogram, they have tested before. Rhombus, they have tested before. Square, they have tested before. Sometimes there are other things that get tested. So please be aware of them. We may not be exhaustive in our lecture notes, but please be aware of the different shapes. Okay, one more example. Example 7 now. Okay, so we're going to put all the skills we have together right now. In your lecture notes, most of the items have been printed for you except a few blanks. Okay, what I want you to learn, okay, is to learn vectors properly. Don't look at you have two columns in your solution. Don't look at the left column, look at the right column. You must learn the theory, you must learn the concept. Okay, so let's start off. Example 7, you are given 3 position vectors A, B, and C. So this is typically, or rather one way by which they actually present your question. They don't give it in column vector notation, they give it in terms of ijk. So are you able to switch all these ijk into column vector? Ask yourself, do you have the ability? How to interpret this? What is 4i minus 9j minus k? In column vector is 4 minus 9 minus 1. Can do things like this. Confident? Okay, do that for the rest of the stuff. So part 1, look at the question. I need to find a unit vector of AB. Okay, I need the unit vector in the direction of AB. So of course I must find AB first. So if you make use of your vectors addition or vector subtraction, whatever you call it, AB is equals to OB minus OA. And so after you pass the first test, write down your vectors in column vector. You activate your subtraction or addition to find your vector AB. So this is vector AB. Have I answered the question? Not yet. I need a unit vector. So unit vector means vector of length 1. What must you divide by? Divide by its magnitude to get this unit vector. So that's how you do your first part. So understand the theory, you will know how to proceed with the question. So far so good? Okay, so please, as I said, before you come in for your next lecture, please read through your lecture notes beforehand. Okay, because things will start to add up, will start to snowball. Right now it's still the initial stage. Once we switch over to chapter 2 onwards, it's going to get a little bit tougher. Okay? Okay, so moving on, part 2, they ask you to find the value of lambda such that A, B, C are collinear points. So earlier on in the lecture notes, I taught you what do we mean by collinear points. But this time round, the question is set differently. I tell you they're collinear already. Find for me lambda. Okay? So what must trigger in your brain are the conditions for collinearity. So for ABC to be collinear, this condition must be met. AB is equals to alpha BC. This is only one possibility. Okay? So in your part 1, you found what is AB. Can I find what is BC? So similarly, via your vectors addition, BC is equals to OC minus OB. That will end up with lambda minus 1 minus 4 minus 2. Okay? Then, if they are collinear, what is the condition? This condition must be met. AB is equals to alpha BC. So put that into your equation. You have something like that. Okay, so this is the first time you see an equation like that. This AB is equals to alpha BC. How do you solve this so-called equation? How many unknowns are there? There's 2. There's alpha, there's lambda. So the trick to handle so-called column vector equation is look across horizontally. So this one generate one equation, second equation, third equation. Okay, so if you look across horizontally, you generate 3 equations. I have 2 unknowns. 3 equations, enough? More than enough. So what is the technique? This one, can you please write down somewhere? Listen, copy down somewhere. I have 3 equations. I have 2 unknowns. Use only 2 equations to solve. Don't use everything. Use 2 equations to solve. So be a little bit smart. Choose the relevant equation. Don't go and use equation 1. Equation 1 so mafan. Okay, so use equation 2 or 3 first. You should be able to solve for alpha very quickly. And then pump the answer back into equation 1. That will give you your lambda. Okay? But typically, okay, the setting of the equation is like this. But most other equations, you need to use 2 equations and verify with the 3rd equation. Okay, use 2 equations to solve and thereafter verify with the 3rd equation. We'll come to an example like this subsequently. So far so good. So once you are done with alpha, now in part 3, they tell you now take lambda is equals to minus 2. Take lambda to be minus 2 and then find for me D such that ABCD is a parallelogram. So if you look at the whole of this question, if you don't have the understanding of what are the properties required of parallelogram, you have no way of doing it. Okay, so you must understand, okay, so if it's a parallelogram, what conditions must be met? Okay, if it's a parallelogram, this condition must be met. Vector AB is equal to vector DC. So do I have AB? Do I have DC? Etc. etc. Go and find them accordingly. You should be able to get your AB. Anybody cannot understand this example. Okay, this kind of example, what's the likelihood of it appearing in the A levels? 0. What's the likelihood of it appearing in your CT1? Maybe got 20 to 30% chance. Okay, it's very, very simple. This kind of examples. A level, no way. We have better things to test you in the A levels. Can I double confirm again? Have you all learned ratio theorem in your secondary school before? Does this formula look familiar? I know it's supposed to be taught in your secondary school. So if I have a diagram that looks like this, okay? So vector CP is equal to lambda times of vector CB plus mu times of vector CA divided by lambda plus mu. Learn this formula before? Never. Some schools teach, some schools don't teach. Yeah, this is what we realize. Okay, but your secondary school teachers should have taught you. But I know some schools don't teach because they felt that it's not really necessary for most of the questions in the O levels. So not to worry. This ratio theorem, I don't expect you to memorize. It is in the formula list. Your MF26 supply this formula to you. So what I want to teach you now is actually very simple, how to use it very quickly. Okay? So if I were to have 2 points, okay, let's call this B, let's call this O, let's call this A, and let's call this B. Okay? What it means is that if they are in the ratio of, let's say, 3:1, okay, what it means is that OD is equals to 3 times of OA. So all you need to do is times across. 3 times of OA plus OB divided by 3 plus 1. Okay, so all you need to do is look across. This is how you activate your ratio theorem. Can? Okay. Memorizing your formula, not important in the formula list. The proof supplied in the appendix 2, so read if you are really interested. Can? So let's have one example let's go through one example. The challenge of this example 8 is not actually on ratio theorem. The challenge of this example is this section that we need to go through right now. So look at the setting of the question again. They tell you that P have this position vector, Q have this position vector. G is on the line segment such that PQ is equal to 3PG. Okay, so I want you to try doing this for me now. G, can you read the question? G is on the line segment. So G must be here. And can you give me the number breakdown? What is this number? What is this number? Based on this condition, PQ is equal to 3 times of PG. So what is this number and what is this number? What's the ratio? Try. If you can do this, good. If you cannot, good luck. Try. Okay, PQ is equals to 3 PG. Give me the number. Able to get the number? 1:2, make sense? All can do it. Okay, if you really cannot, okay, go back, try and do some further reading, or you can see me later. Can? Okay, so if I can break down into 1 and 2. So look at this diagram that you actually just drawn. If I were to put an O down here, do you know what kind of question it is already? It will be a typical ratio theorem question. So when you see something like that, something like PQ equal to 3PG, this is an indicator that you surely will be using your ratio theorem sometime, somewhere in the question. So if you were to do this, activate your ratio theorem formula, fit in the numerical data for OP, OQ, you are done. Very simple if you can survive the first test of writing down 1:2. After you write down 1:2, this magic diagram appear. What trigger in your brain will be your ratio theorem. Okay, so this section, some secondary schools would have covered in probably sometime in your secondary 3 or secondary 4. But for those who have not learned something like that before, please learn it now. Can? Okay, so for those who are done with this question, can you look at example 9? Same thing, you look at the line segment that I drawn for you, ABC. Fit in the number for me. Read the question, fit in the number, the ratio of AB to BC. What is the number? Try. Okay, because that is your fundamental skill. You can do that. The next thing that you use is only your ratio theorem. Are you able to fit in the ratio of AB to BC based on the condition given to you? 2 times AC is equal to 3 times AB. Able to do it? Okay, take note of the setting of this question. Just now G was on the line segment. Now C is on AB produce. So read question carefully. AB produce, that means AB extend out some more. AB produce is different from BA produce. So take note of this. Okay, take note of this box. Vectors, that is direction. So AB produce means extend out from B. BA produce means extend out from A. Okay, so what is expected of you is that you are able to generate this line. Okay, the order should be A, B, C. C should be on the right hand side of B, not on the left of A. Okay, because C is AB produced. What's the number? Anyone can give me the number? 2 is to 1. Okay? If you can do this, what follows next is again back to your usual ratio theorem. Flip around, you can get your OC. But this time round, OC is your unknown. This is your unknown, so just play around with the equation. You should still be able to solve for OC.